Question 1. The length of the common chord of the circle x square plus y square plus 2x plus 3y plus 1 is equal to 0 and x square plus y square plus 4x plus 3y plus 2 is equal to 0 is, we have four options: A 9 by 2, B 2 root 2, C 3 root 2 and D 3 by 2. Then the equation of circle S1 equivalent to x square plus of y square plus of 2x plus of 3y plus of 1 equal to 0, and S2 be equivalent to x square plus of y square plus of 4x plus of 3y plus of 2 equal to 0. Then the equation of a common chord PQ is given as S2 minus of S1, which is equal to 2x plus of 1 equal to 0. We draw two circles, one with the mid point of C1 and C2. This is C1 and this is C2. This will be intersecting inside, therefore we will draw a circle which is intersecting inside with a common chord C1 and C2 at P, and the chord is given as M. Center with C1 is minus 1 comma minus 3 by 2. Center with C2 minus 2 comma minus 3 by 2. Here C1 is given as minus 1 comma minus 3 by 2, and R1 is equal to 3 by 2, which is equal to C1T, and we have C2 which is equal to minus 2 comma minus 3 by 2, which is R2 is equal to 17 by 2, which is equal to C1 of M. C1 of M equal to perpendicular distance from C1 to the common chord. So you can write C1 M, which is perpendicular distance from C1 to the common chord, that is 2x plus a 1 equal to 0. So we get C1M equal to minus 2 plus a 1 modulus upon root 2 the whole square, which is equal to half. Further, now we can see that PQ equal to 2PM. 2 of PM we have C1P the whole square minus of C1M the whole square, which is equal to 2 of root 9 by 4 minus 1 by 4. So in this we get 2 root 2, which is our option B. Therefore option B is the correct answer. Question 2. From the origin chords are drawn to the circle x minus 1 the whole square plus y square is equal to 1. The equation of the locus of the middle points of this chord is, we have four options given in equation, that is x and y. The given circle is x square plus y square minus 2x is equal to 0 if we use x minus 1 the whole square. If we evaluate, we get x square plus y square minus of 2x. Let x1 comma y1 be the middle point of any chord to the circle. Then its equation is s1 is equal to t, or we can write it this as x1 square plus y1 square equal minus of 2x1 equal to xx1 plus of y1. So if passes through 0 comma 0, so we get this as x1 square plus y1 square minus of 2x1 equal to minus of x1. Further we can write this as x square plus y1 square minus of x1 equal to 0. Hence the required locus of the given point at x1 comma y1 is x square plus y square minus x is equal to 0, which is our option C. Therefore option C is the correct answer. Question 3. The equation of the chord of the circle x square plus y square minus 4x is equal to 0 whose midpoint is 1 comma 0 is, we have four options: A y is equal to 2, B y is equal to 1, and C x is equal to 2, and D x is equal to 1. The equation of a chord of a circle is given as x square plus y square plus 2gx plus 2fy plus of c equal to 0, where midpoint is x1 comma y1 is t equal to s1, t equal to x into x1 plus of y into y1 plus of g x plus of x1 plus of y plus of y1 plus of c, and s1 given as x1 square plus y1 square plus of 2g x1 plus of 2fy1 plus of c. Equation of a chord of the circle is given as x square plus y square minus 4x is equal to 0, where midpoint is given as 1 comma 0. So substituting this, we get 1x plus of 0y minus 2x plus 1 plus of 0 y plus 0 equal to, we get this as 1 square plus of 0 square minus of 4. Solving this, we get x is equal to 1, which is our option D. Therefore, option D is the correct answer. Question 4. The pole of the straight line 9x square plus y minus 28 is equal to 0 with respect to the circle 2x square plus 2y square minus 3x plus y 5y minus 7 equal to 0 is for option given A 3, 1, B 1, 3, C 3, minus 1 and D minus 3, 1. We can write the equation of a circle as x square plus y square minus of 3 by 2 x plus 5 by 2 y minus of 7 by 2 equal to 0. We can thus write it as x minus 3 by 4 the whole square plus y plus 5 by 4 the whole square minus 9 by 16 minus 25 by 16 minus 7 by 2 equal to 0, which we can write this as x minus 3 4 the whole square plus y plus 5 by 4 the whole square minus 45 by 8 equal to 0. We put x is equal to x minus 3 by 4 and y is equal to y plus 5 by 4. We get the equation as x square plus y square minus 45 by 8 equal to 0, and line we get as 9x plus y minus 45 by 2 equal to 0. Hence the pole is equivalent to, we get as 9 into 45 by 8 upon 45 by 2 comma 1 into 45 by 8 upon 45 by 2, which we get equivalent. Solving this, we get as 9 by 4 comma 1 comma 4. Further solving this, we get, but if we see x is equal to 9 plus 4 plus 1 by 4, and for y we get 1 by 4 minus 5 by 4, which is equal to minus 1. When we solve this, this is 9 by 4 by 3 by 4. When we solve this, we get as 650, that is we get 12 by 4, which we get 12 by 4 is equal to 3. Therefore, hence the pole we get as 3 comma minus 1, which is our option C. Therefore, option C is the correct answer. Question 5. The inverse of the point 1 comma 2 with respect to the circle x square plus y square minus 4x minus 6y plus 9 is equal to 0 is A 1 comma half, B 2 comma 1, C 0 comma 1 and D 1 comma 0. The equation of the polar with respect to the point 1 comma 2 to the circle x square plus y square minus 4x minus 6y plus 9 is equal to 0 is x plus 2y minus 2x plus 1 minus 3y plus 2 plus 9 equal to 0. We solve this, we get x plus y minus 1 equal to 0. Since the inverse of the point 1 comma 2 is the foot of alpha comma beta of the perpendicular from the point 1 comma 2 to the line x plus y minus 1 equal to 0. Therefore, alpha minus 1 upon 1 equal to beta minus of 2 upon 1 can be written as equal to 1 into 1 plus 1 into 2 minus 1 square plus of 1 square. If we solve this, we get alpha minus 1 equal to beta minus 2, which is equal to minus 1. For the solving this, we get alpha, this is minus alpha equal to 0 and beta equal to 1. Hence, the required point is 0, 1, which is our option C. Therefore, option C is the correct answer. Question 6. The radius of the circle with the polar equation r square is minus 8r root 3 cos theta plus 15 is equal to 0 is, we have four options A8, B7, C6 and D5. Given polar equation is r square minus 8r into root 3 cos theta plus of sin theta plus of 15 equal to 0. Where r cos theta we known as x and y is equal to r sin theta. So if it can be written in a Cartesian form, that is x square plus of y square minus 8 of root 3x plus y plus 15 equal to 0, which is in the Cartesian form. For the solving this, we get x square plus of y square minus of 8 root 3 x minus 8y plus 15 equal to 0. So we get radius is equal to root of 4 root 3 the whole square plus of 4 whole square minus of 15. We get this as 48 plus 16 minus 15 equal to 7, which is our option B. Therefore, option B is the correct answer. Question 7. The locus of the midpoint of the chord of the contact of the tangent drawn from the points lying on the straight line 4x minus 5y is equal to 20 to the circle x square plus y square is equal to 9 is, we are given four options, which is equation x and y. We have given circle equation, which is x square plus y square equal to 9, and the line, that is 4x minus 5y is equal to 20. So the point we have, that is t comma 4t minus 20 upon 5. Equation of a chord AB whose midpoint is h comma k, where we have t equal to s1. Therefore, we get hx plus ky equal to h square plus of k square. Equation of a chord contact AB with respect to P, we get t is equal to 0. We take this as equation 1. So for t is equal to 0, we get tx plus of 4t minus 20 by 5 y equal to 9. We take this as equation 2. So comparing equation 1 and 2, we get h upon t equal to 5k upon 4t minus 20 equal to h square plus k square upon 9. On solving, we get 45k equal to 36h minus of 20h square minus 20k square. Locus is given as 20x square plus of y square minus 36x plus 45y equal to 0, which is our option A. Therefore, option A is the correct answer. Question 8. The point of contact of the given circle x square plus y square minus 6x minus 6y plus 10 equal to 0 and x square plus y square is equal to 2 is, we have four options: A 0, 0, B 1, 1, C 1, minus 1 and D minus 1, minus 1. we have equation of a circle given as x square plus y square minus 6x minus 6y plus 10 equal to 0, and x square plus y square is equal to 2. So we solve, we get minus 6, we substitute the value of x square and y square, which is equal to 2, or we solve further, we get 6x minus 6y plus of 10, which is plus of 2, we get as minus 6 minus 6y plus of 12 equal to 0. For the solving, we get x plus y minus 2 equal to 0. For the solving this, we get x square plus y square plus 2xy equal to 4. We get this substituting the value of x square plus y square, which is equal to 2. We get 2xy equal to 2 for the solving, and we have x minus y equal to under root of x plus y the whole square minus 4xy. We solve this, we substitute the value, we get 4 minus 4 equal to 0. So we get this as x is equal to y and x plus y equal to 2. So the point of contact, when we substitute the value of x and y, we get x is equal to 1 comma y is equal to 1, which is our option B. Therefore option B is the correct answer. Question 9. The point 2 comma 3 is the limiting point of a coaxial system of a circle which x square plus y square is equal to 9 is a member. The coordinates of the other limiting point is given by, we have 4 options which is given in points. We have x minus 2 plus of y minus 3 the whole square, this whole square equal to 0, or we can write this as x square plus of y square minus 9 minus lambda 2x plus 3y minus 11 equal to 0, which represents the family of coaxial circles. Therefore C center can be given as lambda 3 lambda by 2, which is r equal to radius lambda square plus 9 lambda square by 4 minus 11 lambda plus of 9. For limiting points, that is r is equal to 0, where we get as 13 lambda square minus 44 lambda plus of 36 is equal to 0. Further solving this as a quadratic equation, we factorize it, we get lambda is equal to 18 by 13 comma 2. The limiting points are 2 comma 3 and 18 by 13 comma 3 by 2, 18 by 13. When we cancel this as lines up, when we solve this, we get 18 by 3 comma 27 by 13, which is our option A. Therefore option A is the correct answer. Question 10. X square plus y square minus 6x minus 6y plus 4 is equal to 0. X square plus y square minus 2x minus 4y plus 3 equal to 0. X square plus y square plus 2kx plus 2y plus 1 is equal to 0. If the radial center of the above three circle exists, which of the following cannot be the value of k? That is A2, B1, C5 or D4. So we have three equations where we can write that as of x square plus y square minus 6x minus 6y plus of 4 equal to 0. S2 as x square plus y square minus 2x minus 4y plus 3 equal to 0. S3 x square plus y square plus 2kx plus 2y plus 1 equal to 0. Radial axis of circle 1, 2, we take this as equation 1, equation as 2, equation as 3. So the radial axis of circle 1 and 2 are S1 minus of S2, which we get equal to 0, which we get as minus 4x minus 2y plus 1 equal to 0. Further we can write this as 4x plus 2y equal to 1. Radial axis of 2 and 3 is S2 minus of S3 equal to 0, where we get as minus 2 minus 2k x minus 6y plus 2 equal to 0. We get this as 2 plus of 2k x plus 6y equal to 2. So we take this as equation 4 and we take this as equation 5. So the radial center to exist is 4, 2 plus 2k, 2, 6, which should be not equal to 0 from equation 4 and 5. So we solve this, we get 24 minus of 4 minus of 4k, which is not equal to 0, where we get this as 20 minus of 4k not equal to 0, where for the solution we get k is equal to not equal to 5. Therefore option C, which is k not equal to 5, is a correct answer. Question 11. The equation of lattice rectum of a parabola represents by equation y square plus 2ax plus 2by plus c is equal to 0. We have four options given in x. We make a fine adjustment in the equation. We can write that as y plus b the whole square equal to minus 2ax minus c plus of b square. We can write this as equal to minus of 2a x c upon 2a minus b square upon 2a. Equation of lattice rectum is given as x plus lambda equal to 0. Since lattice rectum is perpendicular to our x-axis, so focus is minus a comma 0. So focus can be given as minus c plus of b square upon 2a minus a by 2 comma b. Equation of lattice rectum is equal to minus c plus of b square upon 2a minus a by 2, which is equal to b square minus a square minus c upon 2a. That is x is equal to b square minus a square minus c upon 2a, which is our option C. Therefore option C is the correct answer. Question 12. The locus of the vertices of the family of parabola y is equal to a cube into x square upon 3 plus y square x upon 2 minus 2a is, we have four options given in x and y, which is a, xy is equal to 105 upon 69, b xy is equal to 3 by 4, c xy is equal to 35 by 16, and d xy is equal to 64 by 105. We have y equal to a cube x square upon 3 plus of a square x upon 2, which is equal to, we can write this as a cube upon 3 x square plus of x upon 2 into 3 upon a into 2 upon 2 minus of 2a. For the solving, we get y equal to a cube upon 3 x square plus of 2x 3 by 4a plus of 9 by 16a square minus 9 by 16a square minus 2a. Further, we can write this as the part of this x square plus 2x by 3 4 upon 4a plus 9 by 16a square can be written as a cube upon 3 bracket of x plus 3 by 4a the whole square minus of 3a upon 16 minus of 2a. Solving this further, we can write this as y plus of 35a 16 equal to 4a cube upon 12, that is x plus 3 by 4a the whole square. So vertices will be alpha comma beta. So we get alpha is equal to minus 3 upon 4a and beta equal to minus 35 by a, 35 into a by 16. So, or we can see alpha into beta equal to, can be given as minus 3 upon 4a into 30 minus 35 into a upon 60. We get this as solving this, we get where a get cancelled, we get 105 upon 64, which is we substitute the value of alpha and beta as x and y. The required locus will be xy equal to 105 upon 64, which is our option A. Therefore option A is the correct answer. Question 13. The focus of the parabola y equal to 2x square plus x is, we have four options: A 0, 0, B half, 1 by 4, C minus 1 by 4, 0, D minus 1 by 4, 1 by 8. The given equation of parabola is y equal to 2x square plus of x, which is can be written as x square plus of x by 2 equal to y by 2. So this can be written as x square plus x by 2 can be written as x plus 1 by 4 the whole square, which is equal to y plus 2 plus of 16. We see that we multiply 1 by 6, we add 1 by 16 on the both the side, and we get equation as x plus 1 by 4 the whole square equal to y by 2 plus of 1 by 16. So this further we can write this as x plus 1 by 4 the whole square equal to half of y plus 1 by 8. It can be written as x square equal to half of y, where x is equal to x plus 1 upon 4 and y is equal to y plus 1 by 8. Get a is equal to 1 by 8, that is the focus of 1 is 0, 1 by 8, that is x equal to 0, y is equal to 1 by 8. Substituting this, we get x plus 1 by 4 equal to 0 and y plus 1 by 8 equal to 1 by 8, where we get x is equal to minus 4 minus 1 by 4 and we get y is equal to 0. So the focus of the given parabola is minus 1 by 4 comma 0, which is our option C. Therefore option C is the correct answer. Question 14. Let a circle touches to the directrix of a parabola y square is equal to 2ax, has its center coinciding with the focus of the parabola. Then the point of intersection of the parabola and circle is, we have four options: a comma minus a, b a by 2 comma a by 2, c a by 2 comma plus minus a, d plus minus a comma a by 2. Given parabola has y square is equal to 2ax, where focus is given as a by 2 comma 0 and the directrix is given by x is equal to minus a by 2. As the circle touches the directrix, radius of a circle, that is r, equal to distance from the point a by 2 comma 0 to the line x is equal to minus a by 2. So we have modulus of a by 2 plus of a by 2 upon root 1, which is equal to a. So the equation of a circle B, x minus a by 2 the whole square plus y square equal to a square. Also we have y square is equal to 2ax. So solving 1 and 2, let this be equation 2 and let this be equation 1. So solving 1 and 2, we get x is equal to a by 2 comma 3a by 2. So this will be minus 3a by 2. So putting this value in equation, y square is equal to 2ax we get y equal to plus minus of a and x is equal to minus 3a upon 2 gives imaginary values of y. So required points are a by 2 comma plus minus of a, which is our option C. Therefore, option C is the correct answer. 15. The equation of the common tangent of parabola x square is equal to 10858 into y and y square is equal to 32x is. We have four options given in equation. We write first equation, that is S1 equivalent to x square minus of 108y, that is equal to 0, and we get t is equal to x into x1 minus of 2a y plus of y1, which is equal to 0. Which can we substitute? We get x into x1 minus of 54. We substitute the value of a, and we can write this as y plus of x1 square upon 108, which is equal to 0. So we have the second equation, so we can take that as S2 equivalent to y square minus of 32x equal to 0, which in t equivalent to can be written as y into y2 minus of 2a x plus of x2, which is equal to 0, which can be written as y2 minus of 16 x plus y2 square upon 32 equal to 0. This can further, we can write this as x1 upon 16 equal to 54 by y2 equal to minus of x1 square upon y2 square equal to r, where we get x1 is equal to 16r and y2 is equal to 54 by r. For solving this, we take r is equal to, we get 16r the whole square of minus upon 54 of r the whole square. For the solving this, we get r is equal to minus 9 by 4. We get x1 is equal to minus 36 and y2 is equal to minus 24. Substituting the value of r in x1 and x2 and in y2. So we get y1 equal to 36 the whole square upon 108, which is equal to 12, and we get x2 is equal to 80. So the equation of the common tangent can be written as y minus 12 equal to minus 36 upon 54, which is x plus 36. Solving this further, we get 2x plus 3y plus of 36, which is equal to 0, which is our option B. Therefore, option B is the correct answer. Question 16. The equation of the common tangent touching the circle x minus 3 the whole square plus y square is equal to 9 and the parabola y square is equal to 4x above the x-axis is, we have four options. A root 3 into y is equal to 3x plus 1, b root 3 into y minus x plus 3, c root 3y is equal to x plus 3, and d root 3y is equal to minus 3x plus 1. Any tangent to y square is equal to 4ax and is equal to mx plus 1 by m. If we compare this, we get m is equal to 4 and 1 by m is equal to 0. It touches the circle if 3 equal to modulus of 3m plus 1 by m upon 1 plus root 1 plus m square of modulus, or we can write this as 9 1 plus m the whole square equal to 3m plus 1 by m the whole square. Now from the common tangent to be above the axis, we have 1 by m square equal to 3, where we get m is equal to plus minus of root 3. So we get m is equal to 1 by root 3, we take as positive answer. So common tangent is given as y is equal to 1 by root 3 x plus root 3. So in this further, we get root 3 y equal to x plus 3, which is our option C. Therefore, option C is the correct answer. In 17, three normals are drawn to the parabola y square is equal to x through the point a comma 0. The a value of a, we have four options: a half, p equal to 1 by 4, c a greater than half, and d none of this. So equation of normal in slope form, we have y square equal to 4ax is given as y equal to mx minus of 2am minus am cube, which can be further written as mx minus of 2 1 by 4 m minus 1 by 4 m cube. Since we have y square is equal to x and we get a is equal to 1 by 4, so we can write this as 4mx minus 4y minus of m cube minus of 2m equal to 0. Therefore, we have a comma 0 lies on the normal. So 4m into a minus of 4 into 0 minus of m cube, where we substitute the value of y, we get y and x, m cube minus of 2m equal to 0. So we get this as m square plus of 2 minus of 4a, which is equal to 0, where we get m is equal to 0 and m square plus of 2 minus of 4a equal to 0. So if m is equal to 0, then from 1 we get y is equal to 0. And we take this as equation 1. If we substitute the value of m is equal to 0 in equation 1, we get y is equal to 0. That is, x-axis is one normal. And if m square plus of 2 minus of 4a is equal to 0, where we get m square is equal to 4a minus of 2, write in this as 4a minus of 2 greater than 0, which is a greater than half, which is our option C. Therefore, option C is the correct answer. Question 18. The line Lx plus my plus n is equal to 0 is a normal to the parabola y square plus 4ax is equal to 0. If we have options in equation L and M, so we have Lx plus my plus n equal to 0. Let P be the point, that is minus 80 square plus of 280 be a point on normal, tangency or tangency. Equation of tangent at P80 square comma 280 is given as 280y plus of 2ax minus 80 square equal to 0, which can be written as therefore 2ty plus of x minus 80 square, which is equal to 0. Equation of normal is tx minus y minus lambda equal to 0, where so for the solving this we substitute the value of x and y, we get 2a minus 80 square minus of 2at minus of lambda equal to 0. We get lambda is equal to minus 80 cube minus 2at. Let this be equation 1, and the equation of normal is tx minus of y plus 80 cube plus of 280 equal to 0, which is equation 2. Let this be equation 2. So equation 1 and 2 represent the same line. So applying condition of coincidency, that is the ratios, we get t upon L equal to minus 1 upon m equal to 80 cube plus of 280 upon m. So we get t equal to minus L upon m, where we get n is equal to minus m 80 cube plus of 280. Further, we can write this as substituting the value of t, we can write this as n is equal to minus m minus a l cube upon m cube minus of 2al upon m We can write this as m square n equal to al square plus of 2m square, which is, if we see our answer matches with option B, that is m square n al square plus of 2m square. So option B is the correct answer. Question 19. The point of intersection of common tangent to the conic 2x square plus y square is equal to a square and y square is equal to 4x is the focus of the parabola. We have four options given in equation x and y. Let y equal to mx plus c is a common tangent for x square y square equal to a square by 2, and the condition of tangent c, we have c upon root of 1 plus m square equal to a by root 2. Therefore we get this as 2c square equal to a square 1 plus m square. For y square is equal to 4ax, condition of tangent c we get as c is equal to a by m. Where we substitute the value of c, we get as 2a square upon m square is equal to a square 1 plus m square, where we get m4 plus m square minus of 2 equal to 0, where we get m is equal to plus minus of 1, and we get c is equal to plus minus of a. The equation of tangent c can be given as y is equal to x plus a. Let this be equation 3, or we can say let this be equation number 1, and let this be equation number 2. We have now, let this y plus xa be equation 3, and we have y is equal to minus x or minus a. Let this be equation 4. Solving this both, we get 2y equal to 0, which is equal to y is equal to 0. Substituting the value of y, therefore we substitute the value of y, we get 2x plus of 2a equal to 0. When we solve this, we get x is equal to minus a. So point minus a comma 0, which is the focus of y square, is equal to 4ax, which is our option. If we see, this is y square minus of 4ax, that is, we substitute the value of minus a, so we get y square is equal to minus 4ax, which is our option C. Therefore option C is the correct answer. Question 20. Line lx plus my plus n is equal to 0 will be our tangent to y square is equal to ax when we have four options, a given in a, m and n, l. So given that lx plus my plus of n equal to 0 is a tangent to y square is equal to ax, so we can write this as y equal to minus 1 by m x minus n by m. That is, y square is equal to ax if we have minus l by m x minus of n by m the whole square equal to ax has equal roots. So we can write this as lx square x square plus of n square plus of 2 ln x equal to m square ax. Writing this further as we get lx square x square plus of 2 ln minus of m square ax plus of n square equal to 0 has equal roots. So further solving, we get b square is equal to 4ac, we know that. So substituting the values of b and ac, we get 2 ln minus of m square a the whole square equal to 4l square and n square. Further solving this, we get 4l square n square plus 4 raised to 4 m raised to 4 a square minus of 2 into 2 ln into m square a, which is equal to 4l square and n square. So for the solving, we get m raised to 4 a square equal to 4 ln m square a, where we can write this. We take m square cancel, we get cancel out with m square, we are left with m square a square 4 ln, which is our option D. If we see over here, we cancel a also, we left with m square a 4 ln, which is our option D. Therefore option D is the correct answer. Question 21. A point ratio of whose distance from a fixed point and line x is equal to 9 by 2 is always 2 raised to 3. 2 raised to 3. The locus of the point will be, we have four options: A hyperbola, B ellipse, C parabola, and D circle. We draw a line with a distance of P from M at point h comma k and S at minus 2 comma 0, where m point is 2x is equal to minus 9. So from question we can say that PS is equal to 2 by 3 of PM, which is given, and focus we have S minus 2 comma 0. So equation of directrix equal to 2x minus of 9 equal to 0. We solve this, we take square on both the side, we get PS the whole square equal to 4 by 9 PM the whole square, which can be written as h plus of 2 the whole square, where we have the point of PS, and plus of k square equal to 2 4 by 9 upon 2h minus of 9 by 2 the whole square. Further solving this, we get 9 into h plus 2 the whole square equal plus of k the whole square equal to 4 to h minus 9 whole square upon 4. Further solving, we get 4 4 get cancelled. Solving the bracket, we get 9h square plus 9k square plus of 36h plus of 36 equal to 4h square plus of 81 plus of 36h. Solving this further, we get 5h square upon 45 plus of 9k square upon 45 equal to 1. Further solving this, we get h square 9 plus of k square 5 equal to 1, which is equal to 1. So locus of point PHK is, we substitute the value of HK back as x and y, we get x square upon 9 plus of y square upon 5 equal to 1, which is an ellipse, which is our option B. If you see the equation, we got as ellipse, so option B is a correct answer. Question 22. The locus of variable point whose distance from minus 2 comma 0 is 2 by 3 times its distance from the line x is equal to minus 9 by 2. As we have four options: A ellipse, B parabola, C hyperbola, and D none of this. Let the point be x1 comma y1. So we can write this as x1 plus 2 the whole square plus y1 the whole square, where we take the point that is 2 comma 0, that is the formula of x1 minus 2, where we get minus and minus get plus, so which can be equal to by 2 by 3 x1 plus of 9 by 2. Further solving this, taking square on both the side, we get x1 plus 2 the whole square plus of y1 square equal to 4 by 9 x1 plus 9 by 2 the whole square. Further solving, we take a plus b the whole square on the both the side of both the bracket, we solve the both the bracket, we get 9 into x1 square plus y1 square plus of 4x1 plus 4 equal to 4 x1 square plus 81 by 4 plus of 9x1. Further solving this, we get 5 x1 square plus 9 y1 square equal to 45. We take 45 as a common on both the side, we get x1 square by 9 plus y1 square by 5 equal to 1. Locus of x1 comma y1 is x square upon y square, 9 plus y square upon 5 equal to 1. If we see this equation is of ellipse, therefore option A, that is ellipse, is a correct answer. Question 23. One of the directrices of the ellipse 8x square plus 6y square minus 16x plus 12y plus 13 is equal to 0. As we have four options given in equation, that is y. Given equation of ellipse is we have 8x square plus of 6y square minus 16x plus of 12y plus of 30 equal to 0. Further solving this, we take xx with together, that is 8x square and 16x, where we get 8x square minus of 2x. Same with the y, we take x6 y square plus of 2y plus of 30 equal to 0. Further solving this, we can write this as we add 1 on both the bracket, that is we can write this as 8 of x square minus 2x plus of 1 plus of 6 y square plus of 2y plus of 1 plus 13 minus of 40 equal to 0. So we can write this bracket as x minus 1 the whole square plus of 6 y plus 1 the whole square minus of 1 equal to 0. Further solving this, we get x minus 1 the whole square by 1 by 8 plus of y plus 1 the whole square by 1 by 6, which is equal to 1. So we take x is equal to x minus 1 and y is equal to y plus 1, where we get x square upon 1 by 8 plus of y square upon 1 by 6 equal to 1. So we get a, when we compare this with the equation, standard equation of ellipse, we get a is equal to 1 by root 8 and b is equal to 1 by root 6, where we see b is greater than a. The equation of one of the directress is we get y is equal to b upon e, or we can say y plus 1 equal to b upon e. Where we have eccentricity e as under root 1 minus a square upon b square equal to, where we substitute the value of a square upon b square, we get 1 minus 1 into 6 upon 8 into 1, which is equal to, we can write this as half. So we can write y plus 1, substituting the value of b and eccentricity, we get 2 by root 6 into 1, we get root 2 into root 2 upon root 2 root 3. Further solving this, we get root 2 upon root 3. Further solving, we get root 3y plus of root 3 equal to root 2. Multiplying by root 3 on both the side, we get 3y plus of 3 equal to root 6, which is our option, if we see, is B. Therefore, option B is the correct answer. Question 24. In an ellipse, if the line joining focus to the extremities of the minor axis form an equilateral triangle with the minor axis, then the eccentricity of the ellipse is, we have four options: A root 3 by 2, B root 3 by 4, C 1 by root 2, and D root 2 upon 3. In the given figure, if we see, we draw a figure that is of ellipse. Joining the extremities, that is at x, zero comma b, and this will be b 0 comma minus b, this is equal to y, and this will be y dash. So in the given figure, S is a focus whose coordinates are AE comma 0, and the triangle ABS is an equilateral triangle. So area of triangle ABS, that is area of triangle ABS, is equal to half of into AB into OS. which is equal to root 3 by 4 side to square. We solve this, we get half of into 2b into AE is equal to root 3 by 4 side the whole square. Solving this further, we also have b square is equal to a square 1 minus of e square. So we can write b square, we can substitute the value of b, or we can solve this further as AE upon root 3 the whole square equal to a square 1 minus of e square. For the solve this, we get e square is equal to 3 minus of 3e square, where we get e is equal to root 3 upon 2, which is our option A. Therefore, option A is the correct answer. Question 25. The line 3x plus 5y is equal to 15 root 2 is a tangent to the ellipse x square upon 25 plus y square upon 9 is equal to 1 at a point whose eccentric angle is. Therefore, option pi by 6, b pi by 4, c pi by 3 and d 2 pi by 3. Tangent given as 3x plus of 4y equal to 15 root 2, and the ellipse equation, that is x square upon 25 plus of y square upon 9 equal to 1. Parametric coordinates of ellipse as given as 5 cos theta comma 3 sin theta, and the equation of tangent can be written as x of 5 cos theta upon 25 plus of y 3 sin theta upon 9, which is equal to 1. Further solving this, we have 3x of cos theta plus of 5y sin theta equal to 15. Comparing, we take this as equation 1 and this as equation 2. Comparing both, that is coefficient 1 and 2, we get 3 cos theta upon 3 plus of, that is, we can write this as equal to 5 of sin theta upon 5 equal to 15 upon 15 root 2, where we get theta is equal to pi by 4, which is our option B. Therefore, option B is the correct answer. Question 26. If the line x cos alpha plus y sin alpha is equal to p be the normal to the ellipse x square upon e square plus y square upon v square equal to 1, then we have four options given in equation p, cos, sin, and a and b. So equation of any normal to x square upon a square plus y square upon v square equal to 1 is given as ax of sec phi minus by cosec phi equal to a square minus of b square. Then the straight line given as x cos alpha plus of y sin alpha equal to p will be normal to the ellipse of x square upon a square plus y square upon v square equal to 1. Let this be equation 1. If 1 and x cos alpha plus y sin alpha equal to p represent the same line, so we get a sec phi upon cos alpha equal to minus b cosec phi upon sin alpha, which is equal to a square minus of b square upon p. For the solving this, we get cos phi is equal to ap upon a square minus of b square into cos of alpha, where we get sin phi equal to minus bp upon a square minus b square of sin alpha. Adding this both, or we can say we have cos square phi plus sin square phi equal to 1. So substituting the value of sin alpha, sin phi and cos phi, we get b square p square upon a square minus b square bracket sin square alpha plus of a square p square upon a square minus b square the whole square cos square alpha equal to 1. Further solving this, we get p square b square cosec square alpha plus a square sec square alpha equal to a square minus b square the whole square, which is our option D. If we see p square alpha square plus of sec square alpha a square, sorry, that's a square sec square of alpha and plus of b square cosec square alpha equal to a square minus b square the whole square. Therefore option D is the correct answer. Question 27. The line Lx plus my plus n is equal to 0 is a normal to the ellipse x square upon a square plus y square upon b square equal to 1 if there are four options given in a, b and l and m and n. The equation of any normal to x square upon a square plus y square upon b square equal to 1 is given as ax of sec theta minus by upon into cosec theta equal to a square minus b square. The straight line given as Lx plus of my plus n equal to 0 will be normal to the ellipse of x square upon a square plus y square upon b square equal to 1. So for 1 to represent the same line where we take this as equation as 1 and this as equation 2. So this 1 and 2 represent the same line. So we get a sec theta upon L equal to b cosec theta upon minus m equal to a square minus b square upon minus m. So we get cos theta equal to minus an upon L a square minus b square, and we have sin theta equal to bn upon m into a square minus b square. So we have, since cos square theta plus of sin square theta equal to 1, substituting the value we get a square n square upon L square a square minus b square the whole square plus of b square n square upon m into a square minus of b square the whole square equal to 1. Further solving this, we get a square upon L square plus of b square upon m square equal to a square minus b square the whole square upon n square. So if we check our option B, that is a square upon L square plus b square upon m square equal to a square minus b square the whole square upon n square, which is option B, which matches with the answer. Therefore option B is a correct answer. Question 28. The value of lambda for which the line 2x minus 8 by 3 lambda y is equal to minus 3 is a normal to a conic x square plus y square by 4 equal to 1 is, we have four options: a root 3 by 2, b half, c minus root 3 by 2 and d 3 by 8. We know that the equation of normal at point a cos theta comma b sin theta on the curve x square plus y square by 4 equal to 1 is given by ax sec theta minus of by cosec theta equal to a square minus of b square. So comparing, if we take this as equation 1, comparing equation 1 with 2x minus of 8 by 3 lambda y equal to minus 3, which is given, we get a sec theta equal to 2, b cosec theta equal to 8 by 3 lambda, or we can say AB is equal to 16 by 3 lambda. Let this be 2, where we get A is equal to 1 and B is equal to 2. So when we substitute this value, we get 2 equal to 16 by 3 or lambda is equal to 3 by 8, which is our option D. Therefore option D is the correct answer. Question 29. If the length of the major axis of an ellipse is 17 by 8 times the length of the minor axis, then the eccentricity of the ellipse is, we have five options given, A 8 by 17, B 15 by 17, C 9 by 17 and D 2 root by 17 and E 13 by 17. For an ellipse, it is x square upon a square plus of y square upon b square equal to 1, A is greater than B. According to the question, length of major axis is equal to 17 by 8 into length of minor axis. So that is, if we see, we get 2a equal to 17 by 8 of 2b. Further solving this, we know eccentricity is equal to 1 minus of length of minor axis upon length of major axis, the whole square, which is equal to under root of 1 minus 8 by 17 the whole square. Further solving this, we get E is equal to under root of 289 minus of 64 upon 289. Further solving this, we get under root of 225 upon 289, which is equal to 15 by 17, which is our option B. Therefore, option B is the correct answer. Question 30. The ellipse E1 x square by 9 plus y square by 4 equal to 1 is inscribed in a rectangle R whose sides are parallel to the coordinate axis. Another ellipse E2 passing through the point 0, 4 circumscribe the rectangle R. The eccentricity of the ellipse E2 is, we have four options: A root 2 by 2, B root 3 by 2, C half, and D 3 by 4. Let the required ellipse, that is E2 x square by a square plus y square by b square is equal to 1. It passes through point 0, 4. That will be 0 plus of 16 by b square equal to 1, which we get as b square is equal to 16. So it also passes through plus 3, plus or minus 3, plus or minus 2. Substituting this, we get 9 by a square plus of 4 by b square equal to 1, which is, when we substitute the value of b, that is b equal to 4, we get this as plus or minus 4. So we substitute this value, we get substitute the value of b square directly, we get a 9 upon a square plus 4 upon 16 equal to 1, which is 1 by 4. So which can be written as 9 upon a square plus 1 by 4 equal to 1. Further solving this, we get 9 by a square equal to 3 by 4. Where we solve this, we have a square equal to b square 1 minus of e square. So we get this as a square upon b square, we get as 12 by 16 equal to 1 minus of e square. Further solving this, we get e square equal to 1 minus 12 by 16 equal to 4 by 16, which is equal to 1 by 4, where we get e is equal to 1 by 2, which is our option, if we see, matches with C. Therefore, option C is the correct answer. Question 31. If the eccentricities of the hyperbola x square upon a square minus y square upon b square equal to 1 and y square upon b square minus x square upon a square equal to 1 be E and E1, then 1 upon E2, 1 upon E square plus of 1 upon E1 square is equal to eccentricity of hyperbola, that is x square upon a square minus y square upon b square equal to 1 is given as E equal to under root of 1 plus b square upon a square. So squaring both the side, we get E square is equal to a square plus of b square upon a square. So eccentricity of hyperbola, that is y square upon b square minus of x square upon e square is equal to 1 can be given as E1, that is 1 plus a square upon b square. Squaring both the side, we get E1 square b square plus a square upon b square. Let this be equation number 2. and let this be equation number 1. From 1 and 2 we get 1 by e1 square plus 1 by e square. Solving this, when we substitute this value, we get b square plus of a square upon b square plus of a square plus of b square upon a square. Solving this further, we get 1. Therefore 1 upon e square plus 1 upon e1 square is equal to 1, which is our option A. Therefore option A is the correct answer. Question 32. The eccentricity of hyperbola passing through the point 3, 0, 3 root 2, 2 will be, we have 4 options: A root 13, B root 13 by 3, C root 13 by 4, and D root 13 by 2. If we substitute the value of points, that is 3, 0 and 3 root by 2 in equation of hyperbola, we get 9 by a square is equal to 1. So where we get a is equal to 3 and 18 by a square minus of 4 by b square. When we substitute this value, we get 1 equal to 1. So we get b square is equal to 4. So eccentricity E is equal to root of 1 plus 4 by 9, which is equal to root 13 by 3, which is our option B. Therefore option B is the correct answer. Question 33. The difference of the focal distance of any point on the hyperbola is 9x square minus 16y square is equal to 144. Is the 4 options A8, B7, C6 and D4. The hyperbola is given as x square upon 16 minus y square upon 9 equal to 1. So difference of the focal distance is given as 2a, where we get, if we compare with the standard equation, that is x square upon a square minus of y square upon b square equal to 1. So we get a is equal to, a square is equal to 16, which is a is equal to plus minus of 4. So the difference of focal distance, that is focal distance, is given as 2a. We substitute the value of a, that is 4, we get as 8. So option A is a correct answer. Question 34. The eccentricity of the conic x square minus 4y square is equal to 1. Is, we have 4 options: A 2 by root 3, B root 3 by 2, C 2 by root 5 and D root 5 by 2. Given conic is x square upon 1 the whole square minus of y square by 1 by 2 the whole square, which is equal to 1. We make a fine adjustment so we can get this as equation. So we also have b square is equal to a square e square minus of 1. Further solving, substituting the value of a and b, we get 1 by 4 equal to a square e square minus of 1. Further solving, we get 1 by 4 plus of 1 equal to e square, where we get e square is equal to 5 by 2. Taking a root on both the side, we get root 5 by 2, which is our option D. Therefore option D is the correct answer. Question 35. The length of transverse axis of hyperbola 3x square minus 4y square is equal to 32 is, we have 4 options: A 8 into root 2 by root 3, B 16 root 2 by root 3, C 3 by root 2, 3 by 32, D 64 by 3. So the given equation can be written as x square upon 32 by 3 minus of y square by 8 equal to 1, or it can be written as x square upon 4 root 2 by root 3 the whole square minus of y square upon 2 root 2 the whole square equal to 1. Comparing the equation with the standard equation of hyperbola, that is x square upon a square minus y square upon b square equal to 1, we get a square is equal to 4 root 2 upon root 3 the whole square, which is equal to 4 root 2 upon root 3. So length of the transverse axis of hyperbola is given as 2a, which is equal to, we substitute the value of a, we get 2 into 4 root 2 upon root 3, which is equal to 8 root 2 upon root 3, which is our option A. Therefore, option A is the correct answer. Question 36. The directrix of the hyperbola x square upon 9 minus y square upon 4 is equal to 1 is, we have four options, that is A, x is equal to 9 by 13, B, y is equal to 9 by 13, root 13, sorry, there is 9 by root 13, and C, x is equal to 6 by root 13, and D, y is equal to 6 by root 13. Directrix of hyperbola is x is equal to A by E, and where eccentricity E is given as under root of 1 plus A square upon B square. So this is B square upon A square. For the solving, we can write it as A square plus of B square upon A square, which we get as under root of B square plus A square upon A. We have x is equal to A upon E, so we substitute the value of E, we get A upon B square plus A square upon A. When it goes in the numerator, we get A square upon A under root of A square plus of B square. Substituting the value of hyperbola, that is A square or B square, we get A square as 9, and B square as 4. So we get x is equal to 9 by 13, which is our option A. Therefore, option A is the correct answer. Question 37. A hyperbola center at the origin has transverse axis 2a. If it passes through a given point x1, y1, then its eccentricity is given. We have four options given in x and y and a. Equation of hyperbola passes through x1, y1 can be written as x1 whole square upon a square minus y1 the whole square upon b1 equal to 1. So b1 the whole square. Making a fine adjustment, we get x1 the whole square upon a square minus of 1 equal to y1 the whole square upon b1 square. For the solving this, we get x1 the whole square minus of a square upon a square, which we get as y1 square upon b square. For the solving this, we get b square upon a square equal to y1 square upon x1 square minus of a square. So we have b square upon a square is equal to e minus of 1, that e the whole square. So we can substitute the value of b square upon a square, we get y1 square upon x1 square minus of a square equal to e square minus 1. Please know that this is the formula of eccentricity, where we make a fine adjustment and we can write b square upon a square equal to e square upon minus 1. For the solving this, we get e square equal to y1 square upon x1 square minus a square plus of 1. We can write this as y1 square plus of x1 square minus a square upon x1 square minus of a square. We take root on both the side, we get e equal to under root of we make a final answer, we get a square minus of x1 square minus of y1 square upon a square minus x1 square, which is our option B. If we say a square minus of x1 square minus of y1 square upon a square minus of x1 square, which is our option B. Therefore, option B is the correct answer. Question 38. If the foci of the ellipse x square upon 16 plus y square upon b square is equal to 1, and the hyperbola x square upon 144 minus y square upon 81 is equal to 1 by 25 coincide, then the value of b square is, we have four options, a1, b5, c7 and d9. Hyperbola is given as x square upon 144 minus of y square upon 81 equal to 1 by 25, where we get a is equal to under root of 144 upon 25 and b equal to under root of 81 upon 25. Please note that this is a square of 144 upon 25. When we compare the hyperbola equation with the standard equation of hyperbola, we get A equal to 144 by 25 and B is equal to 81 upon 25. For eccentricity, we get as 1 plus 81 by 144. When we substitute the value of A square and B square, a formula of eccentricity, we get, for the solving this, we get 225 upon 144, which we get as 15 by 12, which is 5 by 4. So the foci is equal to A into E1 comma 0. Substituting this, we get 12 by 5 into 5 by 4 comma 0 equal to 3 comma 0. So focus of ellipse equal to 4E comma 0. That is, when we substitute the value of 4E, we get 3 comma 0, where E is equal to 3 by 4. So B square, hence the B square is equal to 16 minus 1 upon 9 by 16 equal to, get as 7. Please note that we use the formula of B square is equal to A square 1 minus of E square. So we solve this, we get as equal to 7, which is our option C. Therefore option C is the correct answer. Question 89. The distance between the directrices of a rectangular hyperbola is 10 units. Then the distance between the its foci is, before option 10 root 2, B5, C5 root 2 and D20. Since the distance between directrices is equal to, given as 2A upon E, and eccentricity of rectangle hyperbola is given as root 2. The distance between directrices, we substitute the value of E in that, we get as 2A upon root 2. So given that 2A, which is hyperbola, is directress of rectangular hyperbola, is given equal to 10 units. So we 2A upon root 2 is equal to 10. For the solving, we get 2A 10 of root 2. Now the distance between a foci is the distance between foci is equal to, given as 2AE. So substituting the value of 2A and E, we get 10 root 2 into root 2, which is equal to 20, which is our option D. Therefore option D is a correct answer. Question 40. The equation of directrices of the conic x square plus 2x minus y square plus 5 equal to 0 are, before option A is equal to x is equal to plus minus 1, B y is equal to plus minus 2, C y is equal to plus minus root 2, and D x is equal to plus minus root 3. So we can write the equation as x plus 1 the whole square minus y square minus a 1 plus of 5 equal to 0. So we can write this as minus of x plus 1 the whole square upon 4 plus y square upon 4 equal to 1. So equation of directrices is of y square upon b square minus x square upon a square equal to 1, or y is equal to plus minus of b upon e, where we have b is equal to 2 and e is equal to 1 plus 1 equal to root 2. Hence we get y is equal to plus minus of 2 root 2, where we get y is equal to plus minus root 2, which is our option C. Therefore option C is the correct answer.